start recording. Yeah, so like I said, T represents the temperature at any point. Yeah. And then N represents the number of bacteria or viruses at a given temperature. All right, so N is dependent on T. So what that means is that when T increases, N will either increase or decrease depending on the function that has been given this side. So now the question is asking us to find the number of bacteria at 0 degrees. So this one is very simple. In other words, they're just asking us to calculate, to replace 0 where there's T, because this is a function. That's why it's written as N of T. So that's the same as those expressions where you say f of x, meaning the function is a function of x, or that given expression is a function of x. So this given expression here is a function of T. So if they say at 0 degrees, meaning the value of T at this point is going to be 0. So we say N of 0 degrees is therefore going to be 20, while there's T, I'm just replacing with 0, and I'm squaring that, minus 20. I'm replacing this with 0 and plus 20. So meaning N of T, N of 0 is therefore going to be E. This part will give us a 0 minus 20 times 0. This will be a 0 plus 20. So the number of bacteria at 0 degrees is simply just 20. We say 20 bacteria. Same applies to the second question. The second question is also simple. It's straightforward. Yeah, the second question is also simple and straightforward. So here they are saying the number of bacteria at 10 degrees, meaning we're just replacing 10 where there's T there. So you just said N of 10 is equal to 20 times 10 squared minus, let me just write it properly. So we're saying N of 10, I'm saying this is equal to 20 times 10 squared minus 20 times 10 plus 20. So N of 10 becomes 10 times 10, that would be 100 times 20, that's a 2000. And then you have minus 20 times 10, that is a 200 plus 20. So we have N of 10. This is equal to 2000 times 2000 minus 200. That is 1800 plus 20. So that will give us 1820 bacteria. So functions are very simple. These are very simple. Yeah, so now we have this last question which says, at what temperature will the bacteria of will the number of bacteria be minimal? So now this one we're going to apply the concept of the minimum and the maximum. So you can either use completing the square method or that simple method which I told you to say. There's a simple method that you can use to sketch these graphs. So here, what you just need to do is to apply that concept. You can either use the completing of the square method, meaning you're going to complete the square of this expression. And then that part, there's that part which, okay, it's always like this. Let me say you have P there and then you have Q there. Okay, let me put it this way. You have X plus or minus, okay, let me just say plus P, then plus Q this side. Then you have A this side. So there is this part here. If you want to find the temperature at which the number of bacteria will be minimal, you get this part here. And then this part you equate it to 0. You say this is equal to 0, meaning the value of T. So here, in this case, you not have X, but you are going to have T because the function is the function of T, it's not the function of X. So meaning you have something like this. So meaning the value of T when you take P to the other side of the equal sign, T will be equal to negative P. So now, how do you now get the simplest, oh, let me show you the simplest version of this expression. Yeah, so when we completed the square, if you remember very well, this part was x plus b over 2a. Yeah, this is how it was. And then it was squared this side. Then we had some things this side, if you remember during that lesson. So now this part is the one that you get, and it's the one that you use to find the what is the temperature at which the bacteria will either be minimal or maximum. All right, so you just say at maximum, you say at max or minimum, but in this case, we're dealing with minimum, so there's no need of us adding max. So we say at minimum or at minimum, the value of t is negative b over 2a. So from this expression, you can identify your a, b, and c. So the value of t becomes, while as b, we're putting negative 20 there, then everything over 2, while as a, we're putting 20. So we say negative times negative 20, that is 20 over 2 times 20, that is 40. So when you simplify this, you get 1 over 2. So meaning the temperature at which the bacteria will be minimal is simply just T is equal to 0.5 degrees. Or you can just leave it the way it is in a fraction, which is 1 over 2 degrees. Yeah. Do the same. Okay, so this is how simple it is. So the best way or the simplest way to know this is just to master this formula there. So this same simple formula can also be used to sketch the graphs of quadratic equations. Yeah, so if you'd like to learn how to use it, I can teach you tomorrow as the first thing before we even begin to solve the roots of quadratic equations.
Hello.
Yes, sir.
So that formula just showing us, you saying to us we need to memorize. Is that the only formula we use to find the maximum and the minimum?
No, this one will just help you to find the value of x or the value of t at maximum or minimum. For instance, if we get back to this question, let me show you something. If we get back to this question, you remember that, I don't know if there's one who is copying or if there's someone who was writing somewhere. Can you remind us of what was here? It was, okay, let me just try to remember something. We had something like this, f of x.
Wasn't it like, yeah, f of x 2x minus 1 squared?
And then plus 3, eh?
Then, yes.
Yes, we had something like this, meaning the value of x at the turning point of this equation was this part equal to 0. This is what we did. We said x minus 1 should be equal to 0, and the value of x becomes what? Positive 1. And this was gotten after completing the square of this equation, isn't it? So now, using that simple formula, the value of x at the turning point is given by negative b over 2a. So now let us find our a, b, and c from this quadratic equation. So our a is this one, b is this one, c is that one. So now we say x is equal to negative, what is b? B is negative 4. So I'm going to put my negative 4 there. Then everything over 2, my a is what? Is 2. So the value of x at the turning point becomes negative times negative 4. This is 4 over 2 times 2, that is 4. So the value of x at the turning point is what? Is 1. So you see that what we have gotten there is exactly what is there.
Okay, all right.
Yes, so it will only help you to find the value of x at the turning point. So after finding this, to find the value of y at the turning point, you simply replace this same one in the main equation, this same equation that you've been given. So if you replace that one in that equation, you agree with me that if you find f of 1 of this equation, you have 2, 1 squared minus 4, 1 there, then plus 5. And this will give you what? this would be 2 minus 4 plus 5, which gives you what? Positive 3. So now this positive 3 is the value of y at the turning point, meaning your turning point becomes 1, 3. And if you remember, this same 3 is the one that we found there. So you can sketch the graphs of quadratic equations without passing through that whole process of completing the square method. So what, in other words, just what we have found here is what you need to sketch. And also you need also to find the x and the y intercept. So the y-intercept, like I said, if you're using the short method, you just get what is there. So the y-intercept is y is equal to 5. And then to find the x-intercept, you just equate this same equation. Just equate this same equation to what? To 0. So you're going to say, you put 0 there, you're going to have 0 is equal to 2x squared minus 4x plus 5. And when you look at this, this one becomes a quadratic equation, which you can either solve by using the completing the square method, or the formula method, or factorization method. But factorization method for this one will not work. The reason is we solved this and we discovered that it had imaginary roots. So factorization method cannot work. So the only methods that can help you to solve this equation are completing the square method and the formula method. So if you use the formula method, you are going to find at one point that you have the discriminant, you have a negative inside the square root, and that will tell you that the given quadratic equation has imaginary roots, meaning it has no x-intercept. But if you find the values of x, it means that when sketching, the given curve that you're going to have is going to cut the x-axis at 2 points. The first value of x is going to be there. The second value of x is going to be there. That's what it means. Yeah, so I'll find some more questions maybe. In case I forget, please remind me. I'll send some more questions specifically on sketching graphs of quadratic equations so that you can maybe have time to go through them. Yeah.
Right.
All right, and then this one here is also simple. I think tomorrow when we meet, I'll not only solve this one, I'll also maybe get some questions from other sources which we can solve together, which are in this same format, so that at least you get the concept instead of just mastering how to solve this one question.
And what time tomorrow?
Tomorrow, let me just look at my timetable. So we have, okay, tomorrow is Thursday. So I'm teaching ones at 19 hours. So let's meet at 20, 30, somewhere there.
All right.
Yeah. All right, thank you very much. Let's meet tomorrow, 20:30.
Mr. Chanda, please don't forget to share the link.
Oh, all right. Okay, I'll do that.
Sure.
Okay.
Okay, thanks.